Zeal Education Society, redefining excellence.
So hello everyone, I'm Shantanu Pawar and we have got very interesting topic, home automation using Arduino. So without any further delay, let's get started. Good morning everybody. My name is Shantanu Pawar and I am from group number 8 and the title of my project is Home Automation using Arduino. So inside this project, this video is being divided into 4 basic parts. In the first part, we are going to see our strategy to automate the home. In second part, we are going to look at the important components and its information that we have used to communicate our Android mobile phone and automate our home. And in the third section, we are going to take a look at Arduino IDE and the code logic that we have written. And in the fourth section, we are going to see the practical demonstration of how we are going to use it and we are using it. So let us talk about what is our strategy to automate our home. So in this, obviously we are going to use the Arduino, and to pass the information from our mobile phones to the Arduino, we are going to use the ESP826601 Wi-Fi module, and that module will communicate our information from Android phone to Arduino, and using that information, after processing the information, Arduino will control the respective device or relays in case we are controlling the AC circuits. If you don't know, these relays are used to control the heavy loads like LED bulbs, fans or big LED lights, which can be anywhere between 240 volts or 120 volts. So for this, the main components we are going to look at is ESP8266. The second main component is Arduino, and third thing that component we are going to look at is any controlling device like here relays. Anyways, we are going to use the different controlling component. So this chip on this module is known as ESP8266, and it is a SoC microcontroller, and it is 32-bit microcontroller. It also uses RISC processor, and for more information we could obviously check its datasheet. You can see it has various GPIO pins available for functioning, and thus it also has available options for UART. But if we look in our module, there are only 6 available pins for the use. So if you want to take the advantage of all the pins and use this in your project, the node MCU like this, as you can see, it provides a control over all the pins can be used. But currently, as we have only 6 pins available, let us see how to use them and what are they. So these are some technical specifications of ESP8266 chip, and out of which important are it operates only 3.0 to 3.6 volts. This means we will also need a logic level converter to connect it to Arduino. Along with that, it also uses UART communication to communicate the instructions that are being transmitted. This means if we want to communicate the Arduino and our ESP8266 module, then we have to use UART, or you can say serial communication. It also supports I2C communication, but our module does not have options available for it. Also, we have two GPIO pins, and also we are not going to use them. So without any further delay, let's begin. So the ESP module ESP module has a firmware which uses AT commands to communicate with it. Like for example, if Arduino wants to communicate with ESP8266 using the serial monitors, it will transmit the characters AT, and it will so this one is a very basic AT command. And here we are going to see very few basic commands and how we can set the different modes of ESP8266 module, and also we are going to see it practically how to do that. So let us begin. So the first AT command is AT, obviously. So this command is used to check if the AT firmware is present inside our ESP8266. So if we transmit AT, it should respond OK. As you can see at the bottom, the response for command AT is OK. And AT plus reset, as you might have guessed, this command is used to reset our Wi-Fi module. For example, if we pass AT plus RST, our module will restart, which the whatever the Wi-Fi capabilities, or you can say if it was acting as a hotspot or it was connected to Wi-Fi, it will restart all its function, and it will after that respond OK. And the next command is AT plus GMR, and it is again very basic command which is used to check the firmware version, or you can say version of ESP8266 modules firmware again. And it replies with its version, SDK version, and compiling time. But anyways, after this, let's see the few more Wi-Fi controlling commands, AT commands that is used in here. Also, we are going to practically see that here. Now AT plus CW mode. Let us see what does CW mode means. Now AT plus CW mode, this command is used to set the mode of the Wi-Fi module. If we say AT plus CW mode is equal to 1, it is in mode 1. And by the way, there are 3 modes available. In the mode 1, our module will be connecting to external Wi-Fi router, or you can say Wi-Fi. Generally we required a password for that, and after connecting we can transmit the our instructions to it anywhere from anywhere in the world. In the mode 2, our ESP8266 Wi-Fi module will act as a hotspot, and we can connect to it using our mobile phone, but we need to be near our module to communicate, to make our communication from Android mobile phone to our ESP8266 happen. And mode 3 is combination of both the hotspot and a connection to Wi-Fi router mode of our module. And in both the 3 cases it responds OK. Yeah. And in case 1, there are a few parameters that you can give it to it. Another case, in by the way, in our project we are going to use mode 2 because we don't have easy access to Wi-Fi router near us. That's why we are going to use mode 2, which means we are going to use ESP8266 as hotspot, and we are going to connect our Android phone to ESP8266 hotspot. So AT plus CW lab. So this is used to set our Wi-Fi. Yeah, inside ESP8266, it is basically used to set the our Wi-Fi parameters, or you can say information about our Wi-Fi. Yeah, and if our Wi-Fi is in mode 1, to connect to any router or to search for the available routers, uh, this command is used. Suppose there is very common name known as Android AP, which is our Android phone's hotspot, or you can say access point. To connect to this access point, this AT plus CW JAP command is used at in AT commands. AT plus CW QAP, and this command is obviously used to disconnect it from the access point. AT plus CIPSTA. Now this is used to set IP address of ESP8266 module station. AT plus CWSAP. Now this command is used to configure ESP8266 Wi-Fi module in soft access point, or you can say this command is used if we run this command. We are converting our ESP8266 Wi-Fi module as a hotspot. This means our mobile phone can be connected to that. Next is AT plus CWLIF. Now if you want to get the IP address of ESP8266, we have to use this command. And also in our program we have used this command to get the IP address of our ESP8266, obviously. Now rest of the commands we are not going to take a look at that, because now we will practically open the Arduino IDE and we will communicate with ESP8266. So first we are going to upload the blank sketch to the Arduino. And it is been uploaded. Now this is the pin diagram of our module. The first pin is ground, the one below is TXD or transmit, and on the right hand side corner the above pin is RXD or receive, and below it is VCC. And remember, we have to supply 3 volts, or you can say 3.3 volts here, ground here, and TXD here, and RXD here. And we have connected this module to our Arduino in this manner. This is our ESP8266 module, and it is connected. This red is connected to power and black is to ground, and this is RXD and TXD pin. So we just forget one very important point, that is the last second pin from the left side at the bottom. I mean this one, this last second from left at the bottom row. This should be also connected to 3.3 volt, or your ESP8266 module will not work. Now we are inside an Arduino IDE. Let's open the serial monitor, and as you can see, it is set to 115200 because it is the default baud rate of our 8266 module, and you should set this to NL and CR both. Now let us first clear the screen, and when we say AT, you can see it responds with OK. Now let us transmit one more command. I will say AT plus RST. Okay, it says error. Maybe I forget to add the space. Yeah, and when we transmit AT plus RST, you can see it resets and it prints ready at the end. Now let us also open our AT command guide, so we can use this few of this command to communicate. AT plus GMR, let us try that. AT, first of all let's clear the output. AT plus GMR. Yeah, now this is the version which is updated on July 1, 2016, and there is a process by which we can update its version, but currently I'm not going to do it. Anyways, let us again clear the screen, and let us do something useful on our AT, on our ESP8266, sorry. So as we know, we are going to use our ESP8266 as hotspot. Let us also change its Wi-Fi name and password. So for that, we will set our AT to mode 2. So let us type command AT plus CW mode. Oh, sorry, I forget to turn on the caps lock. Yeah, so we will say AT plus CW mode equal to, we want to set it in mode 2, so let us do that. Yeah, so our AT is set to mode 2, and in case we wanted to check what is our Wi-Fi password or hotspot password, let us do that by AT plus CW SAP. AT plus CWSAP. Let us do that. Okay, it says error, we have done something wrong. Okay, so we have to also put the question mark here. Let's try the way. Okay, yeah, so it says so there is no password, as you can see here, and name of this device is ESP928369. Okay, now let us change its password and also the name. For that we have to do is okay, we will type same command, which is AT plus CW SAP, but this time we are going to say equal to its name, and then we are going to add its password. Let us do that. So I want to name it what ETE. Let us name it ETE / automation. Okay, and comma. What is this password? We will set it 12345678. Okay, that is easy password for us to remember. Now we have to say it. We have to obviously enter 1 and 4 after it. I don't know the exact reason for that, but let us do that. Okay, now when we again ask it for what is the password and name, yeah, it is set to ETE Automation, and password is 12345678. Yeah, so we are set with it. Now yeah, that is our ET command setting, and we are going to mostly use these commands in our program. And now let us see what is our program. Now as you know, our ESP8266 is set. I will like to show you the very interesting thing. ET automation name, as you can see, it is available under Wi-Fi, and let us enter our password 123 and let us see what happens. Okay, it is not correct. Now let us enter the correct password 1234. Okay, 1234567 and let us try to connect to it, and it is taking some time. Okay, so it appears that it is maybe not allowing the our what you say, a laptop to connect to it. Okay, so yeah, it is connected now to ETE automation, and thus we can verify that it is been successfully executed our commands. So I hope that you know the basics of Arduino IDE. If you don't know, I will like you to remember that in void setup function is executed one time, and void loop function is continuously executed. So I will explain my program in short. So you can see we have included soft serial.h library. In this library we are allowed it to create a multiple RX and TX communication channels, or you can say we are allowed it to create multiple UART channels. Thus this library is used, and we have created one such channel at pin number 2 and 3, and we will see further why we have created that. And relay 1 to 5, these are the pin numbers that are being controlled. So suppose if we change the command to relay 1, the pin number 9 will change. If we command to relay number 2, pin number 10 will change. So we can change any values here further. Now this is the flags, and it is to indicate that which pin is on and which pin is off. If its value is 1, then it means that it is on. Anyways, inside the serial we have you can see here we have begin the serial monitor, or you can see serial communication as at 115200 hertz. Next we have set all that declared pin as output. Next we have again set all of them as low, or you can say we have set them to 0. And here you can see we are transmitting the AT commands. As a result we are controlling it, and here you can see AT plus reset. As we saw, we are resetting it. Now we are setting CW mode, we are setting its mode to number 2, which is at as a hotspot. And next, if you want to, you saw in AT command guide, if you want to get the IP address of that hotspot, this is the command CIFSR, And if you want to connect multiple Android devices or multiple phones, then CIP mux is equal to 1. So this is to configure it for multiple connections, and CIP server means to turn on the server, and we are also specifying at what port we are going to turn on the server. It is at port 80. Now next in loop, what we are doing is let us see, we are looking here if any data is available from our ESP8266, and if we are waiting here, and if it is available, then this loop is executed or this is ignored. Inside here, what happened is, let us see it. So we are transmitting from our Android phone two numbers, which is pin number 1 and which is second number, pin number and second number. These are the two numbers that we are transmitting, and this is kind of a switch statement, but here we have converted into if statement, and we say if pin number is equal to 1 and second number is equal to 1, we are checking this statement, and then we are turning on the relays on according to it. Like for example, if pin we have transmitted pin number 1 and second number also 1, then we will say relay 1 is on. And if we say pin number 1 second number is equal to 8, then we say relay 1 is off, and you don't have to worry about it, but you just remember the combinations. Like if we said 1 1, then relay will remain on. If we say 1 8, then relay will remain off. And similarly, a kind of number scheme is created for each relay, or you can say each pin number, and this all data is also sent back to our Android phone, that what is on at the current position and what is off, and continuously this thing repeats. And if we ask it to send some data back, this piece of code is used to send the commands back to our Android phone or data to our Android phone. Okay, so now without any further delay, let us try to execute our program. uh, I am okay, just for a second. So I am uploading let us first save it as name. So we will save it to folder. Let's go to, yeah, just a minute. Okay, wait for a second. Yeah, we will create a folder, and inside here we will save our project, and it is, as you can see, compiling, and now it is uploading, and it has successfully uploaded. Now let me connect back my ESP8266 and verify that it is been working. Fortunately, it should be working. Let us see what happens now. Yeah, uh, yeah, let's open the, okay, we have connected the wrong pins. Okay, now let us connect the serial monitor of our Arduino. What happened? So I have connected an LED to pin number 13 of the Arduino, and on the serial monitor I have just opened it here. Sorry. Now what we are going to do is I'm going to press the reset button on the Arduino, and let's see what is being printed on our screen according that we saw in program. Okay, it have printed something, server ready. it might be connecting to it. It is again printing that. Yeah, so here you can see it have printed the IP address. Let us connect to that. Yeah, that's pretty cool. Now from our Android phone, this is the customized app. There are various websites which allow you to make this. I have made one for myself. Now yeah, the IP address and port I have already entered it. Let us see, turning on the device number 5, what happens. You can see LED is turned on, and here we have printed the message LED 5 is on. Now let us turn off it. As you can see, it turns off. Now let's again turn on it. It turns on. Yeah, in this way we have successfully achieved the data communication, or you can say automation of our home using the Arduino and ESP8266. Thank you.
Zeal Education Society, redefining excellence.